STP convergence. In this video, I'm going to talk about the STP convergence. Let me first define the STP convergence. After that, we can talk about some new definition in STP convergence. This is a simple scenario, include switch 1, switch 2, and switch 3. And you know that in this scenario, we have one root bridge, and after that, all of the redundant link with STP will be blocked. Let me to solve this scenario with STP. You know that the switch with the lowest bridge ID is the root bridge. For example, this switch is the root bridge, okay? And after that, we have in each switch one root port. For example, we are using for all of the interfaces 1G interface or 1 gigabit per second. This is the root port of the switch 2 because of the lowest cost to the root bridge. And also this is the root port in the switch 3. After that, we need to find designated ports. The all port of the root bridge is our designated port. This is designated port, and the port 2 also is designated port. And after that, the port 2 of the switch 2 is designated port because it has lower bridge ID than the switch 3. And after that, we have alternate port. This is the alternate port. The role of this interface is alternate. You know that in STP, okay, we have these roles. Let me to review some of the features that we learned about them. STP roles include the root port, okay, then designated port, okay, and block port. But you know that in Cisco we call the block port alternate or backup, okay? But let me to write here block. And you know that we have two type of block, alternate and block, okay? Alternate and backup. After that, we have STP states. The STP state, we learn about that state is forward and block. You know that the root port has the state of forward, and the designated port also has the state of forward, and the block port means the alternate or backup port are the state of block, okay, or has the state of block. Let me to write here, block means alternate or backup, okay? You learn about this feature, okay? Also, you know that in this scenario, when one of the active links, for example, the link between switch 1 and switch 2 failed, okay, this interface should be enabled, okay? Assume that for any reason this link failed, okay? When this link is failing, okay, another interface or maybe more than one interface should be enabled. This alternate should be now the new, for example, designated port, and because of that, here we have the change of state from block to forward. It's so easy. Look at here, because when we don't have this link, let me to remove this link, okay? This interface, the port 2 of the switch 2 now has the new role, okay? And the new role is the root port. As you can see, now here we have forward state, designated port has forward state. Again, we have forward state. Here we don't have a change in state. Here we have only in the port 2 change in the role. But in the port 2 of the switch 2, as switch 3, as you can see, we have changed in a change in the role, and also we have change in the state. As you can see, block now is changing or converting to the forward. Because of that, here we need to for example, understand the process that after that process the block interface can be changed to the forward. Actually, when we are talking about the convergence, our means, or for example goals, is to talking about how many times it takes to converting from one state to another state, and also what is the process in the block to forward changing or converting state, or maybe from in some cases in forward to block. Okay, for example, now this interface is forward. After some second, again this link will be enabled. Okay, when this link is enabled, you know that the this interface, the port 1 of the switch 2 now from the block, okay, should be changed to the forward, you know it, okay, because this is now the root port. And again the question is that how many time it takes to changing the state from the block to forward, and after that for example you know that the new role of this port is root port. Again here the new role of this port again is DP designated port, and we don't have any change in the state because the root port and designated port, both of them are forward, has forward state. Okay, but here you know that again this interface new role is the alternate, and because of that now the forward should be changed to the block. As you can see in this time in the port 2 we have again the change in the state, but from the forward to the block. Actually, when we are talking about the STP convergence, we are talking the processes and the times that we are experiencing when the state of one interface is changing from the block to forward or from the forward to block. But when the state of interface doesn't change and only the role is changed, for example from DP to RP, here we don't have any notation about the convergence because the state is remaining same. Okay, let me to talk about the STP convergence. It is so important for us. Maybe you ask me why the STP convergence is important for us. Let me to talk about first this. Look at here we have this scenario, and now we are working in steady state. This means that everything is okay. And for example here the all of the links are connected, and after that we have the root bridge as the switch 1, switch 2 first port or port 1 is the root port, switch 2 second port, port 2 is designated port, switch 3 is first port root port, and switch 3 second port is alternate port. And you can send traffic from the PC2 connected to the switch 2 to the for example PC3 connected to the switch 3, okay, with this pass. Okay, now we are sending traffic from the switch 2, okay, to switch 1, and after that from the switch 1 to the switch 3. This is the steady state condition, means everything is working good without any, for example, fail. Okay, this is the normal condition. And now this link, okay, is failed. When this link is failed, the communication between the PC2 and PC3 and maybe many other communication will tear down. And because of that, it's so important to, as soon as possible, okay, the pass again establish. For example, it's so important that this alternate, okay, as soon as possible change to the, for example, new role. The new role is DP, and this means from the block to the forward. Okay, maybe you expect to this change occur in only 1 second or maybe less than 1 second, but let me to say that without any reaction, maybe this change occur after 30 or 50 seconds. This means about the 30 or 50 seconds, all of the communication in this path cannot be, for example, established. And this means that our network has many time outage, and this is not good. Okay, because of that, the convergence topic in the STP, in all of the STP topics is so important because we have some tools for reducing the convergence time. We need to reduce the convergence time for faster reaction to the, for example, change in the links. Or also maybe you encounter with another scenario. For example, now this link is not available. This is the steady state, and we are sending traffic from the switch 2 to the switch 3, okay, and from the PC2 to PC3. But after some second, again this link will establish. You know that when this link is establishing, as soon as possible you need to remove this interface or block this interface, because now you have loop.